Hi guys, welcome to lesson 6-3, slope-intercept form, starting on page 101 in your book. So this is all about writing a linear equation from information that you're given, and the first form that you've probably studied before, we want to make sure we can interpret from data and context, is slope-intercept form. So let's get cracking. So what we want to be able to do at the end here is write the equation of a line in slope-intercept form and then use slope-intercept form to solve problems. So they start us off with a little scenario here. When a diver descends in a lake or ocean, pressure is produced by the weight of the water on the diver. As a diver swims deeper into the water, the pressure on the diver's body increases at a rate of about 1 atmosphere of pressure per 10 meters of depth. The table and the graph below represent the total pressure Y, so that's the total pressure because that depends on the depth, on a diver given the depth X underwater. So the total pressure depends on the depth. So depth is our domain, pressure is our dependent variable or our range. So they have a table here and they have a graph and little connection here. Pressure is force per unit area. Atmospheric pressure is defined using the unit atmosphere. 1 ATM or 1 atmosphere is 14.6956 pounds per square inch. That's how much pressure an atmosphere is. Cool to know. All right, so as we get started with the questions here, question 1 says, write an equation describing the relationship between the pressure exerted on a diver and the diver's depth underwater. So using the table and the graph that they gave us there, f of x would be, it starts at 1, that's the lowest, right? So it starts at 1 plus every time it goes up by 0.1 atmospheres of pressure. So plus 0.1 or 0.1 per depth. So every time that we get 1 meter deeper, it goes up 1.1 atmosphere. So there's a function for it. What's the slope of the line? The slope of the line is 0.1. What are the units of the slope? So it is atmospheres per meter of depth. See, that would look like 8 atmospheres over meters. And that makes sense because it's change in Y, which is our atmospheres, over change in X. So atmospheres per meter. What is the y-intercept? Let's see. Well, it's right here where it hits the y-axis. So it would be when x is 0, y is 1. And it means that at 0 depth, so at the top of the water, there is 1 atmosphere of pressure. That's how much pressure there is out of the water. That's how much pressure is on us in the air. So I have a feeling that slope-intercept form is something you've had some experience with, but we want to make sure you're very familiar with all the terminology so you can use it. Slope-intercept form of a linear equation. Y equals mx plus b. M is the slope and b is the y-intercept. So 0, comma b would be the y-intercept. Identify the slope and the y-intercept of the line in this equation. So the slope is always the coefficient of x, so it's -2 or -2 over 1. And the y-intercept would be 0. When x is 0, it's hitting the y-axis at 9. So the y-intercept is 9 and the coordinates are 0, 9. So a little bit of terminology here. A linear equation is an equation that can be written in standard form. ax plus by equals c, when a, b, and c are constants and a and b cannot both be 0. So those are integers that are not 0. math tip. Linear equations can be written in several forms. So we're learning this slope-intercept form first, but there are other forms and we will be learning those too. But this is always the one we come back to. All right, so they want us to create a table of values here using this function, this equation that they gave us. So we're going to use this to find x and y values here. So when I plug 0, why am I saying 0? When I plug -2 in for x right there, -2 times -2 would be 4, plus 9 would give me 13 for my output. When I plug 0 in, I would have 0 plus 9 is 9. When I plug 2 in, I'd have -4 plus 9, which is 5. And when I plug 4 in, I would have -8 plus 9 would be 1. And when I plug 5 in, I'd have -10 plus 9, which would be -1. And we're supposed to put those in the graph. So let's see, -2, 13, 0, 9, 2, 5, 4, 1, and 5, -1. So that's what it will look like there. And this is a linear function, so there's no reason to think that, I mean, there's no context saying this is some kind of real life thing, so that would keep going, and all of the in-betweens would also work. So number 6 is explain how to find the value of the slope from the table. So we do change in y over change in x, and we find out that y is changing. Now this is going by 2's here for these first few. So y is changing by -4. It's going down 4. So we'd have -4. So you'd look for change in y and change in x and make a ratio or a fraction. So we found out y is changing -4 when x is changing 2. So the slope of this line would be -2. -4 divided by 2 is -2. Then it says explain how to find the y-intercept from the table. So we look for where x is 0, and it is 0, 9. Number 8 says explain how to find the value of slope from the graph. And it's sort of similar. We look for the change in y and change in x. So we'll put vertical change over horizontal change. That's what we're going to build. So this one, like let's say from here to here, it has a vertical change of 1, 2, 3, 4 negative, because it was going down, -4, and it went over 2 positive, so it would be -2. And explain how to find the y-intercept from the graph. So look at where the line crosses the y-axis. The y-axis. And that would be right here. And the coordinates there would be 0, 9. So these two things here and here should match. There's just different ways of doing it. You can do it from a table, you can do it from a graph. Either one, you don't need both if you know how to look at them. So we're going to check and see how we're doing here. So number 10 says, what are the slope and y-intercept of the line described by this equation? So hopefully you recognize the pieces. The slope is -4/5. That's the coefficient of x. And the y-intercept is going to be 0, -10, because the b here in this y equals mx plus b was -10. have to be careful with your signs. So number 11 here says write the equation in slope-intercept form of this line. So first we need slope. So we need y equals mx plus b. That's going to be the slope. That's going to be the y-intercept. So we need both of those things. So remember, slope is change in y over change in x. So in this case, it looks like y is changing by -2 when x is changing by +1. So it would be a slope of -2. So now I can build my equation. It would be y equals -2 is my slope. Now I have to look for where x is 0. It'll be right here. Here's my y-intercept, 0, 5. So -2x plus 5 because it's intercepting y at +5 when x is 0. So that's that equation. Make sure you can do this by yourself. It's an excellent question. Write the equation in slope-intercept form of the line with a slope of 4 and a y-intercept of 0, 5. So that would be y equals, slope goes here, y-intercept goes here. Y equals mx plus b. Got to know the components. So write an equation of the line graphed in the My Notes section right here. So let's see, the y-intercept looks like it's right here on 6. So I know that's 0, 6, and I know my b coordinate is 6. So y equals something x plus 6 because it's +6. Now I just got to see, my slope looks like it's going down 2, 1, 2 when it goes over 1. So my slope is -2 over 1, which is -2. So I'd have y equals -2x plus 6 for the slope-intercept form there. All right, so this gets more fun now. We get to do the real stuff. So Monica gets on an elevator in a skyscraper. I'm going to move my microphone here. Sorry if it makes a sound. Okay, she gets on an elevator in a skyscraper. The elevator starts to move at a rate of -20 feet per second. After 6 seconds on the elevator, Monica is 350 feet from the ground floor of the building. So let's just analyze this here. It says that the rate of the elevator is negative. What does that mean in the situation? Let's answer that part first. It means that the elevator, since it's a negative, is moving down. What value in the slope-intercept form of an equation does this rate represent? So that's the rate of change, right? That's how the elevator is changing. What represents that? What does that represent? That represents slope, or m, and y equals mx plus b. So 15a says, how many feet was Monica above the ground when she got on the elevator? So let's think about that. She's been on the elevator for 6 seconds, and she's been losing 20 feet per second, right? And then she's 350 feet from the ground floor at that time. So she's 350 feet from the ground floor, plus she already covered 20 feet per 6 seconds. So she must have started at about 470 feet. Hopefully that makes sense. What value in the slope-intercept form does this represent? To the answer to part A there. That would be, that's her starting point when the number of seconds was 0. So that represents the y-intercept. When x was, which is also b, so when x was 0, when the time was 0, she was at 470 feet. So you can see it gets a little bit more fun when we get to do real stuff with it. So this says, write an equation in slope-intercept form for the motion of the elevator since it started to move. What do x and y represent? Okay, so it would be y equals, remember the slope is negative 20x, negative 20, so that goes with x. Y equals mx plus the starting point when x was 0 was 470. So x represents seconds on the elevator, and y represents the height above the ground floor in this situation. What does the y-intercept represent? We sort of talked about that. It represents when she started, or at time 0, time equals 0, the elevator was 470 feet above ground level. Everything has a meaning. Use the equation you wrote to determine, at this rate, how long it will take after Monica enters the elevator for her to exit the elevator on the ground floor. Explain how you found your answer. Boy, would I love for you to pause this mix and try to fumble around with that for a minute by yourself. So hopefully you realized that we want to find out when she's on the ground floor, what's her height going to be? So on the ground floor, the height above the ground floor will be 0. So we talked about which thing represents the height above the ground. Is that y or is that x? That's y. So if we're going to use this equation and we want to find out how long till she hits the ground level, we're going to say her height's going to be 0, and we're going to have to figure out what x is to figure out how long it took to ride that elevator down to the ground floor. So we'll minus 470 from both sides, and we'll end up with this, and then we'll divide both sides by 20, and we'll end up with x equals, well, divide by negative 20, so you come out with positive time, obviously, about 23.5 seconds. That's how long it's going to take her when you divide both sides by negative 20. All right, that ought to do it for today, and we'll wrestle with some of this in class. So have questions ready and your thinking caps on, and we'll make it happen.